Hello and welcome to the next session on algorithmic problem solving. In this session, we would like to look at the following problem. We have an array of integers, and for an user-defined integer k, we would like to know if that array has a pair of elements a, b, which adds up to k. Now let's move on to the lesson.
We have a sorted array of integers a. For any user-defined integer k, our goal is to detect if a pair of integers in a adds up to k. First, let us look at a simple brute force algorithm. This involves enumeration of all n. Choose two pairs of indices, I, j, with 0 less than or equal to I less than n and I less than j less than n. Let us explore another idea. Consider the example shown here. Let k equals 32, n equals 10. Let the input array be 2, 3, 7, 13, 14, 17, 19, 23, 28, 54. Note that the array is sorted. We initialize two pointers, pointing to the first and last integers in the array respectively. The sum 2 plus 54 overestimates the target value 32. Since the sum 2 plus 54 overestimates the target value 32, we decrement the right pointer. Now 2 plus 28 less than 32. So, we will increment the left pointer now, to get closer to the target. 3 plus 28 less than 32. So, we will increment the left pointer now, to get still closer to the target. 7 plus 28 greater than 32. So, to get closer to the target, we will decrement the right pointer. 7 plus 23 less than 32. So, now we will increment the left pointer. 13 plus 23 greater than 32. So, to get closer to the target, we will decrement the right pointer. Now, 13 plus 19 is equal to 32, and so we have reached the target. Let us apply the same algorithm on another instance of the problem. Here n equals 10, k equals 34. The array given is 2, 3, 7, 13, 14, 17, 19, 23, 28, 54. We need to find a pair of integers from a which adds up to 34. We start with the elements 2 and 54 at the left and right extreme of the array respectively. Since 2 plus 54 greater than 34, we will decrement the right pointer. Now, 2 plus 28 less than 34. This underestimates the target, we will increment the left pointer. 3 plus 28 less than 34. Again, we will need to increment the left pointer. Now we find that 7 plus 28 greater than 34. So, we will decrement the right pointer next. Next 7 plus 23 less than 34. So, now we must increment the left pointer. Since 13 plus 23 greater than 34, we will decrement the right pointer. Next, we find that 13 plus 19 less than 34. This means that we need to increment the left pointer. 14 plus 19 less than 34. So, the left pointer needs to be incremented yet again. Finally, 17 plus 19 greater than 34. Now we have run out of options. We conclude that no solutions are possible. Here is the pseudocode and Python code snippet for the algorithm we illustrated with examples. Assume that the array is already sorted. We initialize the left pointer I to 0 and the right pointer j to end -1. If a, I, plus a, j, equals k, we have a solution. If a, I, plus a, j, greater than k, we have overestimated k and so we need to decrement j. If a, I, plus a, j, less than k, we have underestimated k, and so we must increment I. If j less than or equal to I and we have not found a solution, we conclude that there are none possible. Here is a question. If the input is an unsorted array, how are the two presented algorithms some pairs 1 and some pairs 2 affected? Option A, both algorithms work fine. Option B, neither algorithm worked correctly. Option C, some pairs 1 works fine but some pairs 2 does not. Option D, some pairs 2 works fine but some pairs 1 does not. The correct option is option C. Some pairs 1 works fine but some pairs 2 does not. This is because some pairs 2 requires the array to be sorted before being applied. Another question. Consider another algorithm called SUMPAIRS3 which assumes that the input is sorted. Then for each I, the algorithm binary searches for k minus I within A. If we start with a sorted array, asymptotically which is faster, SUMPAIRS2 or SUMPAIRS3? Option A, both approaches have the same asymptotic complexity. Option B, SUMPAIRS2 is faster. Option C, SUMPAIRS3 is faster. Option D, SUMPAIRS3 does not work. The correct answer is option B, SUMPAIRS2 is faster. SUMPAIRS2 takes order n time and SUMPAIRS3 takes order n log n time. Another question. Consider another algorithm called SUMPAIRS4 which works on an unsorted array. First, SUMPAIRS4 sorts the array using an O log n sorting algorithm. Then for each I, the algorithm binary searches for k minus I. Asymptotically which is faster on an unsorted array, SUMPAIRS1 or SUMPAIRS4? Option A, both approaches have the same asymptotic complexity. Option B, SUMPAIRS1 is faster. Option C, SUMPAIRS4 is faster. Option D, SUMPAIRS4 does not work. The correct answer is option C. SUMPAIRS4 is faster. SUMPAIRS4 takes order n log n time and SUMPAIRS1 takes order n squared time. Thank you. This course is brought to you by Elahay Technologies.